Hello everyone, this is TSS Zindabad and today we are going to discuss the daily challenge of Leetcode, which is implement queue using stack. Let's jump into the problem statement. Implement a first in first out queue using only two stacks. The implemented queue should support all of the functions of a normal queue, which is push, peek, pop and empty. These are the details of the function. So after reading the problem statement, I understand that I need to implement queue, right? So basically, a queue data structure is a first in, first out data structure, right? What does it mean? How is it different? Why are we discussing it? We'll answer all of these questions. We need to implement this using stacks. Now, what are stacks? Stack is a data structure which is last in, first out, right? So you call a queue as a FIFO and you generally call a stack as a FIFO. Now, what is the difference and why am I discussing this for this problem? Let's understand it. For example, you had something like an array, right? It had elements like 1, 2, 3, 4. So these were the elements that were present in my array, right? So what happens is basically I'll consider a queue, right? And I'll consider a stack S. So once you are traversing, right? So you will start traversing from here, that is one, right? It gets added into the queue. It gets added into the stack. Or let's do one more thing. I'll just first do it. I'll just put them first in my queue and then I will put them in the stack. So basically I was standing on the 0th index. I'll add one here. I'll move to the next. I'll add two in the queue. Then I'll add three. Then I'll add four, right? So this is the queue that I have. My pointer will always point to the first element that was added, right? So now let's talk about if this array was added into a stack. So first, my 0th index is added. That means my pointer is pointing towards 1. Then when it goes to the first index, 2 is added into the stack. And now my pointer is pointing to 2. Then when it goes to the second index, 3 is added into the stack and my pointer is pointing to 3. When it goes to the third index, 4 is added and my pointer is pointing towards the fourth index. So if at any point of time you have something like s dot pop, right? Your answer as your pointer is pointing towards 4 will be 4. And if you have something like q dot pop, right? Then your answer will be 1, which is entirely different. Why? Because the stack is increasing upwards, right? Whenever you're getting a new entry, it is getting stacked over the existing entry. When you talk about queue, it is getting expanded in a linear fashion, right? So if you are standing here, these all blocks are getting connected to it on its back. You can take an example of a railways train, right? Wherein the different compartments get connected behind the engine, right? And you can consider engine being something which where my pointer is pointing initially, right? So if you pop it out, then it will go, then it will get incremented, right? For example, here, supposedly, if it's not how it is done, but let us suppose, I'm just giving an example, that here it was on 1, then it goes to 2. So it is getting incremented. But when you pop something out, the pointer gets decremented in the case of stack. So I hope the difference is clear. Now, in the given question, they have said something like you can use at most two stacks. So at most means that you can use the number of stacks which you will be using to implement queue that should be less than or equal to 2, right? So let's start from this value 2 itself, right? So basically you will be given this as a template for writing your code. You already have these functions defined in the class myQ. You need to put your code here, okay? And you will have an input like this, wherein you will be calling the constructor and different function calls will be made, okay? So this is how the input is given to you. Now, after discussing it, let's talk about the approach, right? So when I say let's talk about the approach, I have understood that I am implementing a FIFO, that is first in first out data structure, using a LIFO, that is last in first out data structure, right? I have taught you what is the difference between the two, right? So basically what I do is, as I told you, that let's start that we have two stacks that have been given to us, right? Initially, I am considering that I have been given these two stacks, and using these two stacks, I need to implement them in such a way that they work as a queue, right? I'll quickly copy paste the example here, right? So basically, these were the stack and this was the function that I had. So what is happening is, first this function is called, it is a constructor, right? So after the constructor is called and the object is initiated, all of it, we come here to the next call, that is push. Now, for the purpose, let's create an algorithm so that we know each time we come across any function that is push, pop, empty, or peek, how are we going to solve it, right? So basically, I'll have functions like push, pop, peek, and empty. Okay. Okay. So let's begin with the function push. As I'm standing on this function call and I need to push one, right? The first step that I will do is I'll check if stack S1 is empty or not, right? So basically what happens is, why I have to do this is because from a data structure that works in last in first out manner, I want to have something as first in first out manner, right? So I'll check if stack S1 is empty or not. So I'll have two options, that is yes, it is empty, no, it is not empty. If it is not empty, that means there are certain elements which are already present in my S1, then what I'll do is I'll quickly put those elements in S2. Put X in S2, right? And you have to do this while S1 is not empty. That means put every element that is present in S1 in S2. Supposedly that, see, initially your stack will be empty, right? So in that case, what you can do is, if it is already empty, you just take that element and you push it in S2, right? So push, okay, I'll write it here again. So you will say push X in S2. X is the current value I want to push, right? So according to this, I see that my S1 is empty. So what I'll do is I'll push 1 in S2. Once I have done this, right, my next step will be I'll check if stack S2 is empty or not, right? So basically, if it is not empty, my stack S2 is not empty, in that case, I'll push everything in S1 stack. Why am I doing it is something you'll completely understand once we have a dry run, right? It is basically so that we can use the concept of LIFO as FIFO, right? So I had one here. I'll say while I have any element pending here, I'll simply pop it out, put it in S1, right? So again, you'll get a push. Now, when you got a push here, you have to push 2. So you'll check this first condition, is S1 empty? You will say, no, it's not empty. So what you will do is, you will say, okay, if it's not empty, pop it out from here, put it in S2. So now your S1 is empty and your pointer is pointing to 1 in S2, right? After that, once you are done with it, what you will do is, you will say whatever is now the value, which is 2, you put it in S2, right? It gets added in S2, right? So now you will say while S2, because here we just wrote that the second step will be, if the stack 2 is not empty, put everything back in stack 1. So once you do that, see, now if you see, my pointer was pointing to 2, right? But if you see, this is according to LIFO. That means sec2 was the last element. For example, if I just had these three function calls that were made, that was my queue, push, push, right? So 2 was the last element that was added. But in case, for example, just forget about all of this. If after this we have a pop, my pop will return me where my pointer is pointing to. But we know that the answer should be 1. Why? Because we are implementing FIFO. We are not implementing LIFO, right? So in that case, that is why we have used the second step, wherein I will pop out every element from S2 and I'll put it in S1. So now 2 gets popped out, right? It gets added in my S1. My pointer is again pointing to 1, right? It gets popped out and now 1. So here my pointer is pointing towards 1 in S1 and my S2 is completely empty now, right? So if now the pop call is made, I will get the right answer. I hope this is clear, right? Why have we used these two steps? Now, again, we'll have something like a push. When the push call is made, we need to push a 3. But before that, we need to check if S1 is empty or not. We can see it's not empty. It 1 comes here. My pointer for S2 is pointing towards 1. My pointer now from S1 stack will point to 2. It gets popped out. My pointer is pointing towards 2. I need to add S3. 3 gets added in my S2 and my pointer is pointing here. So again, if I get a pop now, it will give me a wrong answer. It will give me 3, which was the last element that was added. But I need to have a first element when I call a pop function just after this function. So what I'll do is, I'll say quickly add this back in my S1. So it is here on 3, 3 gets added, gets popped out. On 2, 2 gets added, right? Popped out. 1 gets added, pointer in S1 is pointing towards 1, gets popped out, right? So now my S1 is having all of this and my S2 is empty, right? Similarly, another push call is made. Now when this push call is made, we'll remove all these elements, put them here, add the new element and put it back here. So I'll simply do it here only, right? So because I have already told you a lot of times for different elements. So basically I'll have something as S2 will eventually be empty, right? I'll have 4, 3, 2, 1 and my pointer in S1 is pointing towards the final answer. Now, when I get the next function call, which is pop. So what happens in case of pop is, I'll simply return whatever is present on top of S1 stack, right? So you can directly use the dot top function of stacks and you can give it and then you can pop out that element because we need to pop it. So basically pop does two things. It returns you a value and it deletes that value. So as my pointer was pointing towards 1, it gets popped out, right? It is no more in my stack. My pointer will point to 2, right? So then I am again pushing an element. Now I have to push 5. So all of these elements first will be added here. So we'll have something like 2, 3, 4. Then 5 will be added here. Now all of these elements will back be added, right? So then finally what I'll have is, for S1, I'll have 5, 4, 3, 2. My pointer in S1 will be pointing to 2 and my S2 will be empty. Now, if I get a pop, I have to return a 2. Why? Because that was the first element. Initially, we had 1. It has been scrapped. And after 1, we had 2 as the first element. So, we need to return a 2, right? So, we'll simply use the dot top and dot pop function. And similarly, it's done. And as you can see, we've got these pop functions. So this pointer gets decremented. We get a 3. When it gets popped out, we get a 4 and so on. So this is how it's working. Now, in the case of peek function, what we'll say is, we'll say peek means you just have to give me the top element. That means where my pointer is pointing right now, you do not delete that element. Okay. So if you were using a queue directly, you can say that this is dot front function. That means tell me whatever is in the front of my queue, the first element that where my pointer is pointing to, right? So the next function that we need to implement is empty. So you can simply write a code that at any point of time, see, what we're doing is we're initially putting everything in S1, right? Then we're putting it in S2, then we're again putting it in S1. So I just need to check that is at any point of time, is my S1 empty? So it can simply return me a true or false. I think we are good to go. There's one more thing I would like to add before we move forward towards coding it. So guys, basically there's one more approach of doing it, that is using recursion, right? So if you are very confident in recursion, you can easily implement it. It's an easy implementation, right? So herein what you have to do is you can simply use something like a recursion stack space internally, right? Rather than having two stacks, you can just work with one stack. Okay. But if you talk about the space complexity, it still remains O. Okay. So I'll not be doing it separately, but for all the people who like working with recursion, can try this. It's a really easy code, right? So let's quickly jump into coding it and then we'll talk about its space and time complexity. I'll not be doing a dry run because when we were discussing the approach, we did a dry run already, right? But if there is any doubt, you can always comment down in the section. Okay, so this is the code that has been given, right? So basically, publicly, I will initialize two stacks, that is S1 and S2, right? My queue is a constructor that has been called, right? So what we were doing in push was, first step that we were using was that check if S1 is empty or not. Okay, for the function push, what were we doing? We were saying that the first step is that check if stack S1 is empty or not, right? This was the first step we were doing, right? And if it was not empty, then we were saying put all elements in S2, right? So I'll simply have a while loop that will say if S1 is not empty, in that case, what you need to do is have something like int y, have S1 dot top, right? You are accessing the top element there. You'll pop it out from S1 and you'll put it in S2 using the push function, right? So this is y. Then the given X element that you have to push, you'll directly push it in the S2 stack, right? So you'll push X. Now you will again, the second step that we're going to do is that we're going to put everything from S2 stack to S1 stack. Why are we doing this? Because till here, right, from this while loop to us pushing S2 X, right? We are working with LIFO fashion. I want to get a FIFO, that is first in, first out. So I need to invert it, right? So I'll quickly copy paste this code here and we'll just make subtle changes. Here we'll have S2 is not empty. In Y we're getting S2 dot top. We are popping it out from S2 and we're pushing it back in S1, right? It's a void function. We are not returning anything. In the case of int pop, what we have to do is we'll say that you can just have something like int answer, right? Which will have S1 dot top and then you can pop that element which was currently on the top and return the answer. In the case of seek, you can simply return S1 dot top, right? And for the case of function boolean empty, you will return if S1 is empty or not. I think we're good to go. This is the code that we have written. Let's quickly run it and then submit it. And it is working fine. Let's submit it. And yes, it's working fine. Now let's quickly discuss its space and time complexity. So basically, let's talk about the space complexity, right? When you talk about the space complexity, as you can see, we are having two stacks, right? So in worst case, you'll have O of n, that is number of elements that you want to put in the stack, right? So this is, so we know that this code has a space complexity of O of n, and as we have two stacks, right? So further, let's talk about the time complexity. Here you can see this loop is running till you have the number of elements in the stack 1. So in the worst case, there can be O of n elements. Here again, it is O of n elements. In the case of pop, peak, and empty, you will have a time complexity of O of 1 because your pointer is directly pointing to the answer you want. You do not have to traverse and then get it. But in this case, you're going to traverse the whole stack 1 first, right? Then put it there, and in the second while loop, you have to traverse whole the S2 stack and then put it in S1 stack. So the time complexity is of O of n and space complexity is again O of n. As earlier I talked about the recursion approach, it has the very same time and space complexity. If you have any doubts or you want to discuss further, feel free to comment. Please like, share, and subscribe this video. Thank you so much.